Hey guys, today we're going to be talking about proportions. Our strategy to set up a proportion is UKN. U stands for the units, K stands for what we know, and N stands for what we need to know. Our first problem says Angela made 24 cookies with 2 cups of sugar. How much sugar does she need for 96 cookies? So in this problem, when we set up our UKN, we're going to start with our units. This is the 2 things that we're comparing. We are comparing in this problem cookies and cups of sugar. With cups of sugar as your units, you could just put cups, you could put sugar. Really, those units are for you. They're information so that you can identify where your numbers really need to go. So cookies, we know information about 24 cookies and that is 2 cups of sugar. And we need to know information about 96 cookies. So the 96 is going to go on my cookies row. Now, when I go to solve this proportion, I take my information straight from my UKN. And when I'm looking at this problem, I need to see, what do you do from 24 to get to 96? Now, I think it's probably going to be just knowing where I'm looking at 4 and I'm trying to get a 6 at the end. I'm thinking it might be times 4 because 4 times 4 is 16. 4 times 2 is 8 plus 1 does give me 96. So from 24 to 96, my constant of proportionality is times 4. So whatever I do to the top, I've got to do to the bottom, and that is times 4. So we are going to be using 8. Now, we always want to refer back to our UKN because that's going to tell us what is our unit, and that's on the cups row. So that 8 isn't just 8, it's 8 cups of sugar. Sorry about the delay with my pen here, guys. 8 cups of sugar. So in this problem, we were able to pull out the information. We're looking at the 2 things that we're comparing. We set up our UKN, and then we solved our proportion. In example number 2, it says the Moore football team scored 10 points in 5 minutes. How many points would they score in 15 minutes? Now, assuming that we're talking about at the same rate, how many points would they score in 15 minutes? I mean, realistically, we know that football isn't always a proportional relationship, but in this problem, we're kind of looking at that. So we want to set up our UKN. The units, the 2 things that we're comparing are points and minutes. So that goes for our units, points and minutes. We know that this team scored 10 points in 5 minutes, and we need to know how many points will the team score in 15 minutes. So my proportion looks like this. I take the information straight from my UKM to help me set up my proportion. Now I need to solve my proportion. I want to look and see what is the process? What are we doing from 5 to get to 15? And that's going to be times 3. So we're going to times 3 on the top. Whatever we do to the bottom, we have to do to the top because remember, this is just equivalent ratios. 10 times 3 is going to give me 30. And we're going to refer back to what the question is asking. What is our X? What row is it on? We're talking about 30 points. So we would expect in 15 minutes for the team to score 30 points. Again, that's if this was a proportional relationship. And in this problem, that's what we're assuming. It would need to really say at the same rate. How many points would the team score in 15 minutes? Okay, if we look at problem number 3, looks a little bit different because it not only has the word problem, but then it has answer choices with the proportions. A lot of times you're not just going to be asked to solve for the proportion. It's going to ask you to also choose the number sentence or the equation that is written correctly. Now, this can get a little bit confusing, and I'm going to show you guys a strategy that will help you to choose the correct equation, because we know that proportions can be written 4 different ways, and depending on which way you rotate your proportion. So when we look at number 3, it says Stan runs 3 miles every 2 days. Which number sentence can be used to determine how many miles he will run in 8 days? So we're going to set up our UKN just exactly like we did with our last 2 examples. We're comparing miles, and days. So we know that we ran 3 miles in 2 days, and we want to know about 8 days. So my 8 is going to go on my days row. Now my proportion looks like this. 3 over 2 equals x over 8. Now, often whenever we set up our equation, the proportion that we wrote down isn't going to be seen. Now, whenever I look at this proportion, I'm looking for 3 over 2 equals x over 8. I actually do see one that is a match, but sometimes that match isn't going to be there. What I always want you guys to do is to circle your diagonal with your variable. You want to look to see if your diagonal with your variable in your answer choice matches that. You're looking for the x and 2 to be diagonal. And the only answer choice that has x and 2 diagonal was C. And again, this proportion was set up exactly like we had ours originally. Now, just for the sake of solving this proportion and finishing this one out, we would look to see what do we do from 2 to get to 8, and that is times 4. So we're going to do the exact same thing to the top, times 4, and it would be 12 miles. Woohoo, my favorite unit, miles. All right, problem number 4. This will be our last example to take a look at. It says, at the zoo, the ratio of bluebirds to redbirds was 3 to 5. Now, I really like this problem. We've talked about ratios, and we talked about how in ratios, the order is really important. It says that we're looking at the ratio of bluebirds to redbirds is 3 to 5. Well, notice it doesn't say that there are 3 bluebirds, 5 redbirds. It's assuming that you can take the ratio units, the labels, bluebirds to redbirds, and interpret that into our ratio 3 to 5. We know that the bluebirds goes with 3 and the redbirds goes with 5. It says if the zoo has 12 bluebirds, which number sentence could be used to determine how many redbirds that they will have? So again, we're going to start off with our UKN. And the 2 things we're comparing in our ratio are bluebirds to redbirds. And I'm just going to use B and R for my units, because remember, the units are really for you, making sure that you know where your numbers are going to go. Now, bluebirds is 3. Redbirds is 5. That's the information that we know. We know this information. And we're looking at trying to find how many bluebirds how many redbirds there are when there are 12 bluebirds. So I'm going to put the 12 in my bluebirds row, and my variable that I'm looking for is my R for the number of redbirds. So my proportion looks like this. 3 over 5 equals 12 over X. Now, I like this one because if you look at each answer choice, we don't have an answer choice that matches it. 3 over 5 equals X over 12. That's really close, but it's not a real match. Ours should be 12 over X. So this is where we can have a perfect example of where I want you to circle your diagonal with your variable. I am looking for the answer choice that has X and 3 diagonal. Answer choice A has X and 5 diagonal. That's not a match. Answer choice B has X and 5 diagonal. That's not a match. X and 3 on answer choice C is a match, so I feel pretty good about C. But I'm going to look at D, and D has 12 and X diagonal, and that is not a match. So C would be our best answer choice. Now, some of you guys may be thinking, well, wait, Ms. Miles, this one looks different. It's written differently. When you solve your proportion either the example or the proportion that we set up or the answer choice that we have here, you'll get the exact same answer. The only thing that they've done is they reversed the order of the proportion. So we had of the ratio. We had 3 over 5 equals 12 over x, and they just flip-flopped it. They have 12 over x equals 3 over 5. Both of those ratios are equivalent, and you would get the exact same answer. Speaking of getting that answer, let's go ahead and solve this just to get a little bit more practice in solving proportions. To get from 3 to 12 is times 4, and 5 times 4 gives me 20. Now, one thing I want to just remind you of real fast, if you're looking at your, trying to find your constant from 3 to 12, in this one it was pretty easy for us to see that it was times 4. If this ratio over here, where your fraction is, can never be reduced, you may need to reduce that fraction in order to find your constant. Sometimes it's not as visible with the way that the ratio is written, and you might have to reduce that fraction as well. So hopefully these 4 examples have kind of given you a little insight on how to solve and set up proportions, and this will help.